Hey everyone, and welcome. Today, we're diving into a Leetcode problem called type of triangle. It sounds simple, and it is, but it's a good one for practicing some basic geometry and conditional logic. We'll break it down step by step, so no worries if you're just starting out. Let's get to it. So here's the gist. We're given a list of 3 numbers. Let's call this list. These 3 numbers represent the potential side lengths of a triangle. Our job is to figure out what kind of triangle they can make. First, can they even form a triangle? If not, we say, if they can form a triangle, we then need to classify it. Is it? That means all 3 sides are the same length. Is it? That means exactly 2 sides are the same length. Or is it? That means all 3 sides have different length. The input is always a list of 3 positive numbers, which simplifies things a bit. Let's look at an example. Suppose our input list of numbers can view as 3, 3, and 3. Since all 3 sides have the same length, this is an equilateral triangle. So the output should be the word pretty straightforward, right? Okay, how about this one? Our input list is 3, 4, and 5. First, can these sides form a triangle? Well, 3 plus 4 is 7, which is greater than 5. 3 plus 5 is 8, greater than 4. And 4 plus 5 is 9, greater than 3. Yes, it satisfies the rule. Since all 3 sides, 3, 4, and 5, are different lengths, this is a scalene triangle, so we'd return. Now, what happens if the numbers can't actually form a triangle? Let's say our list has the numbers 1, 2, and 5. If we take the 2 shorter sides, 1 and 2, and add them up, we get 3. The third side is 5. Is 3 greater than 5? Nope, it's not. So these 3 lengths cannot form a triangle. In this case, the answer is. This brings us to a very important rule in geometry called the Triangle Inequality Theorem. It sounds fancy, but the idea is simple. For any 3 lengths to make a triangle, if you pick any 2 of them and add their lengths together, that sum must be greater than the length of the remaining side. You have to check this for all 3 pairs of sides. Checking all 3 pairs can be a bit tedious. But here's a neat trick. If we first sort our 3 numbers from smallest to largest, let's call them side 1, side 2, and side 3. Where side 1 is the shortest and side 3 is the longest. Once they're sorted, we only need to check one thing. Is side 1 plus side 2 greater than side 3? If the sum of the 2 shortest sides is greater than the longest side, then it's guaranteed that the other combinations will also work out. This makes our life much easier. So our game plan looks like this. First, we'll take our list of 3 numbers and sort them from smallest to largest. Second, we'll do that simplified triangle check. Add the first 2 smallest numbers, and see if their sum is greater than the third, largest number. If it's not, then these sides can't form a triangle, and we just say. But if they can form a triangle, then we move to step 3, figuring out its type. We'll check if it's equilateral, then if it's isosceles, and if it's neither of those, it must be scalene. Alright, here's how this logic looks in Python code. Don't worry if it seems like a lot at once. We'll walk through each important part. The main idea is to follow that plan we just discussed. First things first, we sort our list of numbers, which we're calling. Most programming languages have a built-in way to do this. So if started as, say, 5, 2, 4, after sorting, it becomes 2, 4, 5. This puts the shortest side first, and the longest side last. Next up, we check that crucial triangle rule. Remember, because X is sorted, the item in a set CX0 is the shortest side, and the item at index 2 is the longest. The item at index 1 is the middle one, so we take the item at index 0 and add it to the item at index 1. If this sum is less than or equal to the item at index 2, it means our 2 shorter sides aren't long enough to meet over the longest side. So it's not a triangle, and we return the word. Okay, if we've passed the previous check, we know for sure we have a valid triangle. Now let's see what type it is. First, we check for equilateral. Since our list is sorted, if the shortest side, the item at index 0, is equal to the longest side, the item at index 2, it means all 3 sides must be equal. For example, if is 3, 3, 3, then the item at index 0 is 3, and the item at index 2 is also 3, so it's equilateral. If it's not equilateral, it might be isosceles. An isosceles triangle has exactly 2 sides of equal length. Again, since ERISE is sorted, we just need to check 2 possibilities. Is the first side, item at index 0, equal to the second side, item at index 1? Or is the second side, item at index 1, equal to the third side, item at index 2? If either of these conditions is true, then we have an isosceles triangle. For example, if is 2, 2, 3, or 3, 4, 4. Finally, if our sides do form a triangle, but it's not equilateral, and it's not isosceles, well, what's left? It must be scalene. This means all three sides have different lengths. So, if none of the previous conditions were met, we just return. So how efficient is this approach? It's super efficient. For time, we say it's big O of 1, or constant time. Why? Because we're always dealing with exactly three numbers. Sorting three numbers takes a fixed, tiny amount of time. And the few comparisons and additions we do also take a fixed amount of time. It doesn't matter if the numbers are small or large. The number of operations is always the same. For space, it's also big O of 1, or constant space. If the sorting happens, meaning it modifies the original list directly without needing a new one, then we're not really using any extra memory that depends on the input size, which is fixed anyway. So very memory-friendly. So let's recap the main points. The heart of this problem is the Triangle Inequality Theorem. The sum of any two sides must be greater than the third. A key trick to simplify this is to sort the side lengths first. Then, you only need to check if the sum of the two shortest sides is greater than the longest side. And finally, the order in which you check the triangle types is important to get the logic right. First, see if it can even be a triangle. If yes, check for equilateral, then isosceles, and if it's neither, it's scalene. Hope that breakdown made sense and helped you understand the type of triangle problem. If it did, feel free to hit that like button, maybe subscribe for more Leetcode explanations, or drop a comment if you have any questions or other ways to solve it. And hey, if you're feeling extra generous, there's always the Boba Fund. Every drop counts. Keep practicing, keep coding, and I'll catch you in the next one.